Hey guys, Mr. McKinney here, just doing a quick example of tangent line equations, but also involving implicit differentiation. So this would be an incredibly difficult equation to try to solve for y. But if I want to write the equation of the tangent line, I don't need to solve for y. I just need to know what dy dx is at this point. So I need to find an equation for dy dx. But I don't even really need an equation that's solved for dy dx. I just need the value of dy dx at this particular point. Now, anytime you're asked to write the equation of a line, you're going to use point-slope form in calculus. So y minus y1 equals m times x minus x1. This gives you x1 and y1. So the only piece I need is m. M would be dy dx evaluated at this point, at the point x1, y1. So I just need to figure out what dy dx is at this point. And if I can figure out what that is, then when I plug it in, I'll be able to plug everything into the equation. So it seems complicated, but it's really fairly straightforward. You just have to be careful at each step. So in order to find the slope of this equation, to find dy dx at this particular point, I'm going to need to take the derivative. And since I'm not solved for y, I'm going to use implicit differentiation to take the derivative. So let's start with sine of x times y. The derivative of sine of x times y would be cosine of x times y, and then the derivative of x times y. So I have to use the product rule here. X times dy dx plus, and then the derivative of x is 1 times y equals x is 1, or sorry, the derivative of x is 1. The derivative of 2y would be 2 dy dx, and then the derivative of pi goes away. Now this is where you can make the problem easy or complicated. If you try to solve for dy dx right now, it gets fairly ugly. So don't. As soon as you've taken the derivative, you're allowed to plug in the point. Don't plug in the point in the original equation, otherwise everything's a constant. But as soon as you've taken the derivative, now I can plug in my x and my y. So I would get cosine of 1 times pi over 2 times x is 1 dy dx plus 1 times pi over 2 equals 1 minus 2 dy dx. All right, let's see what we can simplify over here. So cosine of pi over 2, that turns into 0. And since that's 0, this whole thing is 0. So I would get 0 equals 1 minus 2 dy dx. And we were fortunate that that was 0, but a lot of times in the AP exam, stuff like that will happen. Otherwise, we would have had to multiply some things out and move dy dx over to the same side. But since this whole side turns into 0, now I can just add the 2 dy dx over. Whoops. So 2 dy dx equals 1. To find dy dx is 1/2. Now this is not all the time. The slope is not always 1/2. It's 1/2 at that point. So at the point 1 pi over 2. So when I write my final answer to this equation, I'm just going to use point-slope form. So y minus y1 is pi over 2 equals my slope is 1/2 times x minus 1. Now, an important thing to notice is that if you're given a point and you want to find the slope at that point, you can plug the point in as soon as you take the derivative. Just like when we're doing differential equations and we're trying to find that plus c value, you can plug the point in as soon as you integrate. So don't plug it in into the original equation, because then everything's a constant. But as soon as you take the derivative, you can plug that point in, and then you can figure out the slope at that point. You could also do all the work to solve for dy dx and then plug the point in. You'll get the same answer. It's just a whole lot more work and you'll run out of time on the AP exam. So anytime you're writing the equation of a line, always use point-slope form. The slope will come from the derivative and you can plug in the point as soon as you have taken the derivative. So you guys try on your own. All right, let's see how you guys did. So derivative of cosine should be negative sine. Derivative of x times y should be x y prime plus y. X prime goes away. As soon as you've taken the derivative, we can plug in our point. This time this doesn't go away, but it just turns into negative 1. So I distribute the negative 1, I get negative dy dx minus pi over 2. I have 1 minus 2 dy dx on this side. When I add 2 dy dx over, it becomes a positive 1 dy dx. And then I add the pi over 2 over, and I'm done. So dy dx equals this. It's only at the point 1 pi over 2. Keep in mind that this is not always the slope, but we only needed it at this particular point in order to write the equation of the line tangent to that function at that point. So this was just a quick refresher on how to write the equation of a tangent line. Remember that you always want to use point-slope form anytime it asks you to write the equation of a line. All right, we're going to pick up the word problems in the next video.